it's a great community to be involved in, and I think many of us in this panel have been involved in the community for quite some time. So we thought we might finish off the day with a discussion around the impact of cloud on research and higher education and how that might change over the next 10 or 20 years, really thinking forward, being a bit speculative around what could happen and what's coming up. So I think we're all aware that digital as a technology is transforming the way we do stuff around the world, and it's certainly turning our notions of how research is conducted, how we collaborate, completely upside down. And I think we're really just beginning to see the impact and the potential changes of what might happen over the next 5, 10, 20 years in research. Cloud, APIs, these things are becoming the new language of research, and cloud is certainly one of the new technologies that is increasingly being applied to the art of discovery. Big questions and big research, like the SKA, like our Large Hadron Collider and God Particle Project, do need to already speak this new language, and this language connects all of these international compute platforms. It also connects humans and minds to these compute platforms. So the question really for the panel today is to think about, what are we doing right now in aid of this vision, and what is coming. So we might just kick off with a quick introduction to each of you.
I introduce myself. Is that how
yeah, that's okay, right. That's how we do it. It won't be like earlier in the day, no.
So I'm Dr. Steve Quenette. I'm at Monash University, and similar to Steve, we sort of have a large part of guiding how the institutions invest and actually deliver environments of computing and everything else for our researchers and Australia as a nation overall.
Sarah Nisbet. I'm the Marketing and Communications Manager at eRSA, and that's my title, but I'm not sure if it describes what I do. So eRSA is sort of like the South Australian provider of NeCTAR and RDS services. I've been involved in some marketing activities for NeCTAR, and at the moment I'm managing the Cultures and Community Project, which is a eResearch infrastructure investment in the humanities and social sciences that's been going since about 2013.
I'm Paul Coddington. I'm one of the Deputy Directors of NeCTAR. So I'm responsible for the National Research Cloud in NeCTAR, and I have a background in sort of high-performance computing, grid computing, cloud computing, scientific computing for more years than I care to admit. But yeah, so I've been working on NeCTAR only for the last several months, and that's my background.
Great. So thank you. Welcome, everyone. So I might just kick off with a question to Steve next to me. So Steve, you've been involved in developing, strategizing, thinking about Monash University's cloud. That cloud has been funded through the program that NeCTAR has run over the last 5 odd years, and I think you guys have done some pretty awesome innovative stuff around building your platforms on top of cloud. So I guess the question really is let's just get straight into it. What do you think cloud on campus is going to look like in the next 10 or 15 years?
So I think to answer that question, it's useful to understand how we understand this problem. And most people think of cloud as a consumer grade thing, and we very much think of it as a domain-specific thing. It's about a particular group of people and what they want to do. And so the notion, and many of the people in this room would have heard this before, we talk about what is the 21st century environment for discovery. And so we talk about, let's start that conversation by thinking about the humble microscope. So a microscope, it was this thing that mankind invented a couple of hundred years ago, and we invented it because we could reliably machine brass, and we could reliably machine lenses. And we put them together, and we used the sunlight to put in a sample, and essentially light was transformed from the sunlight through the sample, through filters and knobs, up this brass channel to a lens. And a researcher was able to go off and say, hey, look, I've discovered this thing for the first time, and I can give you the dial settings, and it was able to share and disseminate that knowledge, and others were able to repeat it. The result of that was the advent of biology and basically the Faculty of Medicine and universities as we see them today. Really, the way we see the world is that brass is software. right? The machine that creates the light is your synchrotrons, it's your cryo-EMs, it's the major instruments, it's whatever creates your big data source, your LHC or whatever. So then straight away, it's data that's traveling up this thing, this brass, right? This software that we're creating. And then we need to create computers and software and create an environment where these computers and software can actually exist, so that the data can be transformed, can come up, and a researcher can create that tool, integrate the whole lot. A domain expert can do that and then share that with others. And so we talk about the 21st century microscope that way. And if you take that view, then quite quickly, the most important thing you can do is create a software-defined open environment that lets you do all of that brass. And your guys can be the guys that can build the best brass instrument.
Yep.
And that's very much how we see the world. So the campus, how does the campus work in the future? Then takes that same paradigm and say, well, if you're the place that you choose to create that software and that infrastructure needs to extend that through that openness through to computing, through networking and everything else. You have to choose a home for that. But the front door will probably always be with you as an institution, because if you're paying the bill, you'll be able to consolidate many of those people together, like we cloud providers are doing now with containers. Work out the cost efficiency equation, work out what point you do it in-house and out-of-house, and so on and so forth. And so the future of the campus cloud, I think you'll see that the networks go beyond the data center, and that network goes all the way to the instrument, and that will probably drive some level of investment always on campus.
Yeah.
But it will feel like a HSM of how your computing goes off to somewhere else where it may be cheaper or something else.
Yeah. Cool. Do we have any other comments around that? Anyone know? So maybe over to you, Sarah. I guess the natural kind of relationship to that is thinking around these kind of specific communities, around these specific international, consortia. So in your case, you've been heavily involved in culture and community research, social sciences, historical studies and so on. There's been, I think, over the last 3 years in particular, some significant work happening in Australia on trying to transform how research happens within those communities. So where do you think that's kind of going, or how is that, as a start, that research been impacted with cloud?
Yeah, so I come from a humanities and social sciences domain, and I think the thing about being here today and sort of, what I know about our area is just that the maturity level is so different. What we're kind of, the things that have been enabled through CNC are things like standards and attitudes and just basic access to tools. So, what we're trying to do is almost like building an inspiration culture. So it's sort of saying, hey, guys out there who are kind of working within their institution, it's like, what do you want to do? What international examples are out there that you want to follow? Like who's the sort of the god in your mind in the research sector, and how can we do that in Australia with the investment that we've got? So really what we're kind of looking at doing is, sort of setting those standards, building that community, building that culture. And that's not to say that there aren't sophisticated HAS tools projects out there. I think what's next is sort of getting those people to think about those, individual projects and how you can sort of connect them together and collaborate, and having that underlying infrastructure that enables you to interact internationally.
So there is already a diverse array of stuff happening at very local levels, but it's around how do we bring it together and engage them with?
Yeah, absolutely. And, and there's, fairly sophisticated projects out there like, AusStage and AusLit, and the one that we're working with, the Prosecutions Project, which is sort of, a cultural heritage project that's looking at all of the historical trial records around Australia, taking them from physical records in archives, getting them digitised and then transcribing them so you can actually run, analysis over them, and starting to see some trends in, trial data across our history. And, Mark Finane, who's the research leader on that, ARC funded, he looks to the Old Bailey online in London, which is, looking at all the London trial records.
Yep.
And that's, for him, that's his goal. It's like, okay, how can we sort of replicate that and interact with that? And in some cases, he's actually got a harder job because the Old Bailey online is just, one
element
one,
of
one sort of trial record, whereas in Australia it's, we've got all the, different colonies and, all those sort of extra issues of, being an unfederated nation. When a lot of these records.
Are there any examples internationally where cloud plus new methods has really transformed an area of humanities and social sciences? What are some kind of are there any big key examples out there?
I think it depends who you ask. There's a group called Europena who are sort of providing lots of different tools readily available for research use. That's something that we're looking at in terms of when we were sort of developing the scope for this project, whether we could recreate that. I mean, just the different levels of investment mean you kind of a little bit hamstrung in what you can do. But in terms of what we can do, we're definitely trying to conform to an international standard so that those collaboration and networks we can tap into.
Okay. And a question for you, Paul, around, I guess you mentioned earlier today when we were speaking, when you were giving your talk, first thing in this room, this morning in this room, was around international efforts, and I guess it all kind of plugs into what we've been speaking about so far. What is the connection to, in the last 5 years, there's been a proliferation of institutions, consortia, science projects internationally, countries, South Africa, Brazil, and so on, thinking about establishing OpenStack clouds. What is what is happening, I guess, really in that space? How are we progressing a more international, collaborative, collective agenda?
Yeah, so I think the answer is until fairly recently we really haven't been. So I think NeCTAR was, as I said, was one of the leaders, the leader, I guess, in this field of putting together a federated national scale cloud, particularly around OpenStack. I think there are some other initiatives using other cloud platforms. And prior to the cloud, there had been initiatives around grid computing, federations, and just HPC centres sort of federated. Some are sent in Europe and the US, predominantly a ground grid. But the last few years there's been a huge uptake in let's see if we can do that for cloud. So CERN is an example. I mean, the Higgs particle and all the work that was done at CERN was predicated on having a huge worldwide distributed compute and storage sort of federation, but it was mostly based around HPC centres and grid computing interfaces and things like that. But just in the last couple of years there's been a big change within CERN. They now have an enormous OpenStack cloud put together, and I think the original driver of moving to cloud was actually to say, well, let's try to leverage off commercial clouds. Let's try and we have this huge compute and storage requirement. Maybe we can use Amazon or something like that. But in fact, how it's panned out is that they've essentially started to run their own kit because it's more cost effective, and it's they can provide stuff at huge scale just the way they used to do, but using cloud instead of HPC and grid, and that's starting to get a lot of uptake, I think. So there are a number of groups now that are doing not so much national scale but regional scale federations, within a state, so in some cases within countries, and then in Europe trying to move towards, continental scale things. Yeah. So it's been a huge advance in the last couple of years, but they haven't, I think, been particularly integrated. Even in Europe, there's the concept of the European Open Science Cloud that's starting to be pushed. And in Australia, there was recently come out the National Research Infrastructure Roadmap, which did say we should try to align with what's happening with the European Open Science Cloud, which makes sense, but that's still a fairly vague thing. It's more aspirational and actually in place, but it basically does say we have been essentially told we must make sure we align or interoperate with international efforts, which makes sense. But that's still very early days around how to do that. So there, as I said, in the last OpenStack Summit, they kicked off a new initiative around what's called the Open Research Cloud Congress or Open Research Cloud Declaration, which is starting to push this. You know, all these groups are running their own clouds or own research cloud federations. Almost all of them are using OpenStack, but they're all doing it in a different way. They're not really haven't addressed the issue of interoperability apart from within their own federation. So how do we try to address that? And as I said in the talk this morning, you know, to a large extent that's because how do we support international research collaboration? So most research is done collaboratively. They're, you know, predominantly with at least the important research is done in international collaborations. So, you know, the example I gave this morning, you know, if you've got people in an international collaboration, there might be people in Australia, the US, Europe, Brazil, whatever, in this big international collaboration, they've all got their own local cloud compute resource in their own country. They would like to make use of all of that. So, so how do they do that in a way that's seamless and interoperable? And it's not quite there yet. Everything from the authentication to, you know, allocations to, you know, similar sorts of middleware. So I can just pick up this application here and run it over there. I mean, obviously there's a lot of advances in containerization that make that easier, but that's work. You know, there's still some work to be done on how to pull that together. But there's certainly, you know, there's a lot of interest. There are a lot of people, a lot more people than I expected at this meeting in Boston. There was a lot of interest from a lot of the big players there, so I think that will progress more and more. And I suppose there's sort of two aspects to this for us. So partly in NeCTAR, we are providing just basic infrastructures, cloud infrastructure as a service. Here you go, spin up your VM, off you go, do what you like kind of thing. And then on the other hand is sort of what Sarah and Steve were talking about, is a lot of the work is more research discipline specific. I'm in this particular research area. I collaborate with people internationally in that area. These are the tools we want. These are the data sets that are important to us. We want an online environment to be able to access that data, analyse that data, use the compute resources in a seamless way. So the other part of NeCTAR is developing what we call the virtual laboratories or the science clouds to provide that more research discipline specific tools, and that is being done in a much more internationally cooperative way. Because, you know, we use tools that are developed overseas and vice versa.
Thanks. Before we launch into more questions, are there any questions from any of you for this very experienced, knowledgeable panel? Any questions anyone has on anything?
I'm happy to make a further comment on Paul's thing, which is, you know, one of the emergent and beautiful thing of 5 years of the NeCTAR Research Cloud is if you go to the image catalogue, there's something like 400 or some vast number of images. You know, and you can't expect any researcher to go up and say, I know which ones to use. And so one of the projects that we, as NeCTAR, has invested over the last couple of years is to create something like the Ubuntu, you know, certified images or whatever else in there. And only in the last couple of months we were able to sort of go live with that within NeCTAR, and those things are really, really useful because it's actually targeting our user community to create those things, and they then need to support it, and then they get a bigger badge or whatever else, and then people know to use those ones and they feed themselves. And then that comes into this sort of conversation of, well, what's the right medium for sharing that domain-specific, say, virtual lab or tool or whatever else? And so there's containers. Images aren't quite right because they're kind of node-specific. Some people don't like root. Some people allow you to have root and all those different things. And one of the collaborations that is starting to form is, and together with people like Jetstream, which is an equivalent of NeCTAR in some ways in the US, I mean, there's shades of grey about that, is, you know, taking a much more software-defined approach using Ansible as sort of the golden image thing. You can stamp that, you know, and I think the world will move into this sort of ecosystem where there are multiple ways through containers, through Ansible, through images that we sustain and we create these researcher applications, not just, you know, not just web app, LAMP stack, and, you know, the typical commodity cloud things.
Okay. So that leads on to, I guess, a broad question, and maybe for each of you to answer, is around, there is, I think it's clear that research, higher ed, both across industry and higher ed is going to be an absolutely huge use case for cloud and cloud technology, cloud computing, data clouds and so on over the next decade. What is the recipe to better connect research practice to that technology? I mean, I know various disciplines engage with technologies in different ways, and I think everyone has their own way of engaging with communities, engaging with new tech. Do you have an answer, Sarah, or thoughts on that from your
I don't know if
experiences?
it's an answer, but one thing that sort of has been popping into my mind as I've heard Paul and Steve talk is, one of the biggest challenges in HAS is the data, and what is it and where is it? And, in humanities, it's sort of, it's an actual physical record that's not digitised in an archive, and in the social sciences side, it's, getting close to having difficult ethics requirements and things like that. So the next challenge, it's sort of like, okay, how do we curate these data sets and make them available for research and interrogation? And if we can sort of curate them and make them available in a way that starts to look like it is in some of these other domains, like characterisation, then putting it close to, the compute and the cloud and the storage and the HPC, we can start to open up whole new ways of thinking in this HAS sector. And so for me, it's like, okay, we've got opportunities moving forward to explore that and to connect up these data sets that exist, but are kind of only interrogatable, if that's a word, through the platform that they exist in, so there's Trove and you can access that through the Trove API, or, there's Honey and you can access that through Honey, or there's the Paradisic data set and you can access that. But how do you sort of go across them, and what sort of standard would you use, and what sort of workflow, and then how do you add to that corpus as well? So, those are the kinds of questions that I'm starting to think about, and how we can talk to the community about, of where we're going, and that might sound a bit backwards, but that's where we've kind of got to start at the moment. But I think in the time that all these cloud innovations have sprung up in Australia through the NeCTAR investment, HAS has matured, and I think we're there now and ready to sort of learn what we can from these other disciplines and domains,
and have those data conversations.
Take those tools and capabilities and apply them to this HAS sector.
Yeah. Paul, what are your thoughts?
Yeah, I think it's very dependent on. There's a huge spectrum of IT awareness and capability across the research sector. So I think, I saw the same thing in the early days of high-performance computing, parallel computing. There are people that are, very smart, very technically minded. They had a difficult problem they needed to solve and need a lot of compute power. They were willing to jump through almost any hoop to, if you gave them the resource to do that, write their own programs, learn how to do parallel computing, et cetera. And so I think the early days of cloud were a bit like that. It was a bit difficult, it was a bit flaky, it was a bit, so there's some real effort to get it up and running, to do what you want, and certain people of a technical bent were willing to do that, and had complicated things they need to do. But there's that's a minority of the research space, right? So most people, it has to be simple to use. It has to be not much more difficult than using their PC.
Yep.
And you have a lot of applications where people are using their PC, but they just need a little bit more grunt, a little bit more data. They have to access stuff that's only available online. They don't have to download it. And as long as we make it easy for them to do that, I think they'll jump at it. But we're still on that path, from infrastructure to platform and software as a service, to having online, virtual laboratories, online environments that are easy to use, web interface, etc. Or we have, as Steve was pointing out, we have these images that were created by the community, or containers that were created. Here's all the software you need to do this work. You don't have to bother installing it on your PC and keeping it up to date and doing all this and that. Someone else has done that for you. Here it is. This is all you have to do. Get on the cloud, away you go. So we're getting very close. I mean, certain disciplines that's already there. We already have some quite good VLs and quite good images for certain spaces. But as that broadens out to a wider variety of research disciplines, I think we're just going to get more and more people jumping on board.
Yeah. Okay. Yeah, question from the audience.
Someone mentioned this morning that the cloud is just someone else's computer. When they are doing research, in fact, the cloud is someone else's computer and perhaps someone else's software and perhaps someone else's data. So the problem of data provenance is very important in this context. Could you talk a little bit about what's been on in your, say, in the context of NeCTAR or inside Monash to deal with this kind of thing? How can I reuse data that has been generated by other researchers if I don't know how this has been generated, which version of the software was used, where this, what kind of input was used, etc.?
It's kind of funny because I know Steve cares about this topic. I don't know if you want to actually answer first.
I'm the MC. I think. No.
I think
happy to answer.
There is a. Oh, do you? You go. You might as well.
No, you go ahead.
Okay. I mean, there's a spectrum, I think, of ways of answering that. As infrastructure or cloud proponents are pushing it, I guess we're not necessarily responsible. The researchers do exactly the right things, but as an institution, you do care. And I think there's shades of grey between research where there is no issues around data provenance and data securities, and then there's the social sciences and medical sciences where ethics will basically say if you take this data, you're fully responsible for what even might happen downstream. Right? And so if you take those shades of grey, you've got to be able to create, these microscopes, these reliable machineries, these virtual labs, these whatever else, that can deal with that entire spectrum. On the medical space, and 50% of Monash's research income, and same with the University of Melbourne, and same with Sydney and whatever else, is basically health and medical sciences and social sciences. And we have to contend with how do we make the cloud available to those people. In that case, what we have to be able to do is say, well, here's a catalogue of information you want. Your ethics said you can get it. You can do all the compute, and we make Hadoop, we make all these things available to you, HPC, whatever else, but you cannot get that data off. And before you can get that data off, you've got to tell your governance behind that data. You've got to ask them if it's okay for that data to come off. And you have to then look at how you orchestrate that workflow and deal with those sorts of problems. Perhaps we're a little bit ahead of the game because we're thinking that way, but invariably, because the liabilities will fall back on people who have to be responsible for these sorts of things, we have to be able to orchestrate this open cloud in this environment that then also protects the data securities behind it, which then sort of also leads to sort of provenance and things like that. If we end up with these golden images, hopefully those golden images, and this is coming from my geophysics background, this is very normal how we work. You cannot make a code and have the community accept it if it doesn't pass the benchmarks of every single code that existed beforehand. Every single code is benchmarked on a paper that's in Nature or something else. So that's the way that we see provenance works. We don't really care about the sort of traditional library way of thinking of, say, provenance. We care about, well, what does research think about it? You've got to pass the test. It's like a regression test. Every new application has to repeat all the regression tests of the past, and those tests are not whether the software passes, it's whether the science actually passes. And then if that links to golden images or the equivalents, whatever it might be, then I think that's really the future of those sorts of works.
You have anything to add to that? No. Look, I'll just quickly say that the problem you've described is because 30 years of computational science is all about analytics, and it's only now that data provenance is coming to the fore because of the volumes of data and the complexity of data. So I think it's just a matter of time. We're going to start building all those processes in. It is a process thing mostly. Like one of the national programs that's related to NeCTAR is RDS, and within Victoria, at least, is my example. We had a process where we ingested data sets, but there was a structured process to ingest. Why am I using this? To ingest those data sets. Sorry, so there was a process to ingest those data sets, and we knew who the custodian was, what the conditions of access were, who it was available to, how long it was available for, the metadata around it, and so on. It was a very expensive process in terms of time, but it means that we have hundreds of available data sets where all those things are now extremely well defined. I think the reality is that if you value your data, that's it's a process you have to go through. And then we have other cases like geoscience data sets, geophysics data sets, climate data sets, which are available on central repositories on supercomputers at NCI in Canberra. And again, they're very well defined, looked after, expensive, et cetera, et cetera. So I think that probably we can talk about it much more later on. I know we're kind of running out of time. So before we close up, are there any other questions from the audience that anyone would like to ask? It is a little bit after 5 and we do need to get to the main room to finish up, and then it's drinks time. So, all right, we might finish up there. Thank you very much to Paul and Sarah and Steve for joining me on the panel. And thank you all very much for coming along today and sticking around for the session this afternoon. Thanks.